You know, when you look out into space, you see billions and billions of galaxies. And at first glance, this one, Messier 106, it just looks like another pretty spiral. But trust me, it's hiding something extraordinary, a cosmic secret so powerful, it literally helps us measure the entire universe.
So here it is, Messier 106. It's sitting about 23 million light-years away in the constellation Canes-Venatici, so not exactly next door. And yeah, it looks like a textbook spiral galaxy, right? But those beautiful, elegant arms, they are not the whole story. Not even close. There's something else going on in there, something truly bizarre that had astronomers scratching their heads for decades.
All right, so let's peel back the layers and dive right into the secrets this galaxy is hiding.
Okay, so here's the central mystery. M106 has its two normal star-filled spiral arms, the kind you'd expect to see. But then it has these two extra, kind of ghost-like arms. These things, called anomalous arms, aren't made of stars at all. Nope, they're composed of incredibly hot gas, and get this, they don't follow the galaxy's rotation. They just slice right across it.
So what in the universe could possibly create these enormous, glowing structures that just cut right across the galactic disk like that? To find the answer, we have to go right to the very heart of M106.
At the center of this whole mystery is an engine, a seriously powerful engine, a true monster at the galaxy's heart. At its core, M106 has a quasar, and a quasar is basically a supermassive black hole that is actively feeding. It's gobbling up gas and dust, and as that material spirals in, it gets superheated to millions of degrees, just blazing with X-ray and radio light. This cosmic engine, well, this is our prime suspect.
So, how does a hungry black hole create those weird ghost arms? Well, the answer involves a natural phenomenon that sounds like it's straight out of science fiction, a cosmic laser.
The key to all this is something called a MASER. It's an acronym, and it stands for Microwave Amplification by Stimulated Emission of Radiation. I know, it's a total mouthful, but the concept behind it is actually something you're probably very familiar with.
We all know what a laser is, right? A focused, powerful beam of light. Well, a maser follows the exact same physical principle. It's just operating at a different wavelength. Instead of visible light, it amplifies microwaves, a type of radio wave. And the most amazing part is that these things occur completely naturally out in space.
So how does nature build one of these cosmic lasers? It's a pretty cool three-step process. First, you've got all those X-rays blasting out from the quasar. They pump energy into nearby clouds of water. This shoves the water molecules into a super excited high-energy state. Then, all it takes is one passing microwave photon to trigger a massive chain reaction, causing all those molecules to release their energy at once as a perfectly focused, intense beam of microwaves.
And this isn't just any old maser, it's a MegaMASER. It's been supercharged by the quasar's immense energy to be about 100 times brighter than any maser we've found in our own galaxy. This incredible power makes it way more than just a curiosity. It's a vital scientific tool.
You see, this MegaMASER acts as the ultimate cosmic yardstick, letting astronomers measure the distance to M106 with just stunning accuracy. The method is just surprisingly elegant. Radio telescopes can actually track individual maser spots, these bright little clumps of water vapor, as they orbit the black hole. By measuring their speed and their tiny movement across the sky over several years, astronomers can use some pretty simple geometry to calculate a direct, physical distance to the galaxy itself. And the result? A distance of 7.6 megaparsecs, which works out to about 24.8 million light-years. Now, the precision of this measurement is simply astounding for an object that's so far outside our local group of galaxies.
This isn't just a number, it's a benchmark. The original researchers called it one of the most precise absolute extragalactic distances yet measured. Think about that. This single, highly accurate measurement acts as a crucial anchor point for pretty much all of cosmology.
Okay, so we've got a powerful engine and a precise distance. But that brings us all the way back to our original mystery. What about those ghost arms?
So, how does the black hole's engine connect to these strange structures? Well, the solution is just incredible. The anomalous arms, they aren't arms at all. They are the glowing edges of two enormous bubbles of gas being inflated by powerful jets shooting out from the black hole.
We're actually seeing the shock waves, where this massive outflow slams into the rest of the galaxy. So, solving this one mystery revealed a cosmic ruler. But the importance of M106 extends far, far beyond just this one galaxy. Because we have such a precise, direct geometric distance to M106, it serves as what we call a geometric anchor. We can observe other distance indicators in this galaxy, like certain types of stars, and calibrate their true brightness with extreme confidence. This calibration then lets us measure distances to even more remote galaxies, strengthening every single rung of the cosmic distance ladder, the tool we use to measure the size, age, and expansion rate of the entire universe. M106 looked like a perfectly normal galaxy, but it held the key to a cosmic laser and a new way to measure the universe. It really makes you wonder, as we build more powerful telescopes and look even closer, what other profound secrets are still out there, hiding right in plain sight?